The battery is back. Yes, this is the Frankenstein Battery. It is still alive. Hi. Yeah, we've got a negative. We've got 0.2 amps outside, and we are in 2% state of charge. This is the same day as in the previous video. The same shit weather and the same low state of charge of my system. What happens if I turn off this light? Oh yeah, we've got 0.8 amps then. It's pretty good. I mean, we are getting 188 plus 25 watts. All the lights will help us to find the right connections of the batteries here, right? And I still don't know how to tell my wife that we don't have hot water today. It is just enough for one light. Yeah guys, anyway, welcome back to the Off-Grid Garage here. The Frankenstein Battery is back in the battery room. So in this Frankenstein Battery we have got 5 different models of batteries, all connected in series, even with different bus bars, and they also have different terminals. Single stud welded terminals, flat terminals with M6 threaded studs, and here we have double pole terminals. And all these cells are beautifully connected with these flexible bus bars made by the Digital Mermaid. I link her channel down below. She is currently converting a sailboat with diesel motor to fully electric. So have a look, maybe that's something for you. And if you haven't seen the details about this battery here, I link this all down below. There's a whole series about the Frankenstein Battery project and how and why this all happened. But in today's video we want to install the front plate here and a JK-BMS connecting to all these wonderful battery cells here. Because this is still an unfinished project for quite a few months now, maybe a year. But today I want to finalize it. I want to connect the BMS because I desperately need another battery. And a while back I also made a video about these front plates you can buy, and they actually kind of fit the Seplos do-it-yourself boxes. So you can actually replace the Seplos BMS inside these batteries with a JK Inverter BMS using these front plates. And unfortunately the holes are not lining up 100%, so you have to modify some of the holes a bit to make it work. And also the paint quality of this panel is not the best here. But for now we are just using it. This is all we have. What I didn't think about is the actual fuse holder here. I don't have an appropriate fuse holder to fit on this bracket, but I will get one. But the whole front panel also comes with the, what is it, 3.5-inch display or something for the JK Inverter BMS, and this pops just in and then connects to the BMS later on. So, and I want to install the JK PB1A 16S 10P. So that's a 100 amp BMS with a 1 amp active balancer. Oh, it says it down here anyway, so you can read it yourself. And this actually fits perfectly fine on these studs up here. Yeah, like this. Nice. And we've got the communication board, which goes over here. Sits on these studs, and we also have the terminals somewhere. I think I've got actually a full box here with Frankenstein battery accessories. This must be all the leftovers from the Seplos BMS and the do-it-yourself box. Ooh, we also got Chinese chewing gum. Nice. That is so yummy. That is the best Chinese blueberry. Yeah, and it still has the display here from the Seplos BMS. Ooh, and the fuse holder. Question is, will it fit? Will it fit? Will it fit? Oh, it actually does fit. Nice. And a 400 amp 80 volt fuse. Nice. And I've also have all the bus bars and also the terminals here, still originally packed. Woo! And now you think, wait a minute, Andy, 400 amp fuse, that's a bit too much for this BMS and all the cabling you probably install. This would mean like a double 70 square mil cable at least, maybe even double 95 square millimeter. We will have an external circuit breaker for this battery here, which limits the current to 80 amps only. So this is only for direct short protection. Alright, I'm having a look through all these plastic containers here with leftover screws from other do-it-yourself boxes. If I can find some screws to hold these terminals in place here. You may need to use different screws for all these terminals. But hey, that's a Frankenstein battery after all. So different screws are perfectly fine. So far I could only use one of the Seplos bus bars connecting from the main positive of the battery box here to the fuse. Yeah, this is pretty much the same as it was before with the Seplos BMS installed here. And I could modify Frankenstein this bus bar here to make it work for the P negative. So that's the output of the BMS, connects over here, and then it wiggles down somewhere over here, and these two connect perfectly to the two negative bus bars of the battery box. So that is great. And then I have potentially, I can use this one here for the main negative. If I bend this one here, hang on, if I bend this one 90 degrees like this, it goes all the way to the top. And we can probably reuse one of these holes, and I drill a new hole, because this one needs to connect to the main positive. Oh no, hang on, it goes over there, positive here, negative here. It needs to connect to this terminal. Damn it. Okay, we have to mount the BMS first and see if we can reuse one of these here. And this one here maybe for the positive somehow. But wait, I've got heaps more of these ones. Okay, I wouldn't call this heaps, but it is a start. These ones obviously don't work. They are used for circuit breakers. And then we have these ones which are only half of this size. They're also not as thick as these ones. Nah, I don't think so. Well, if we can't find the appropriate bus bars, we have to make our own with cables. I just realized the fake front panel actually comes with some sort of screws, at least the ones for the BMS and the communication board, and some other screws. I don't know what they are for, but here there are more screws. I think I've got the bus bar sorted. It's kind of Frankenstein sorted. So this long one here, which needs a bit more cooperation here to go in the right direction, will go here to the positive of the fuse, yeah, like this, and then it goes all the way around and connects here to the main positive of the battery. You can't see that shit because the camera, and here to the main positive of the battery. So it needs a bit of heat shrink on this side. It needs a second hole over here to fit this double pole terminal, and I cut off the excess here of this bus bar. Nice. Then I've got this one here going from the B negative of the BMS, dink, over here to the negative of the battery. Simple as. Unfortunately, this is just a smaller bus bar here, but I think it's good enough for a Frankenstein battery and 80 amps. Boom! It'll work. It'll work. Okay, from here to here. Another hole here. and I can cut it off there somewhere. And I need heat shrink until here. So this needs to be all heat shrinked. Cut off here, another hole here, heat shrink. Okay, I've got everything ready. Goes here on the fuse, and there goes a washer, spring washer, nut. We have to modify this clear case then, because the cable in and outlet is only straight up and down, but we are now going sideways. So in here, let's see if this fits. Oh, that looks good. There's two. There's our positive link. Frankenstein style. So, and here we are. SF5 goes here to the fuse and positive terminal, SF7 negative terminal BMS, and the SF2 goes from the fuse to the positive terminal. Nice. And I can't read what this one actually means here. M something, I don't know. This will be our negative connector from the BMS to the battery. Hey, that is actually pretty cool that we could reuse all these bus bars here. And it looks really Frankenstein style, right? Boom! I left it that messy on purpose. It looks terrible. All these bus bars here, they are pointing in different directions and then are squeezed in to fit on the terminals. But now everything fits together. That's all fine. I'm not sure if this is actually the cabling harness we discovered to be faulty from where we did the troubleshooting and the other BMS, you know. So we will see. If this one doesn't communicate, it is the cabling. Alright, I would say let's put this bad boy in. Okay, let's see if we can make it work with these holes here at the front. That is terrible. They're just not lining up. I've got 3 screws in on the front panel. I mean, we have seen worse, right? But whoever designed this front panel here as a replacement for the original Seplos do-it-yourself box, or Mason battery box I should say, did a terrible job, because these holes are not lining up correctly to these holes. You can see the offset here. Yeah, look at this. And the whole front panel is actually 1 millimeter, 2 millimeters too wide. See how it bends over here on the corner? Isn't that terrible? You wonder sometimes, stuff coming from China is so good, so precise and so advanced in technology and design and everything. And then you get crap like this again. We say, well, they still stuck in the 70s when everything from China was cheap and didn't last long and was poorly designed. Well, this front panel is one of it. That is just terrible. Hence, it fits the Frankenstein battery so well. Now, unfortunately, we have to crimp all the balance cables with M6 ring lugs. When was the last time we did this, actually? All the do-it-yourself boxes these days, they have actually PCBs across the cells, and you just have these pre-configured JST connectors, plug them in and you're ready. This is something we haven't done for a while, right? But needs to be done. I'm not going to show you anything of that. There's no time lapse. It will be just ready to go in 3, 2, 1. Of course, I have linked this down below. And we're also leaving this cover for the fuse off. It doesn't do anything anyway. Okay, I actually wanted to do a time lapse to organize all these cables here, but I want to turn on the BMS first and see if it actually works. But I've just seen I've forgotten to install the main positive of the BMS here. There needs to be a little... This cable is not in the box here anymore. Damn it. Found it. So it should be the last cable to connect. It's good, no spark, no smoke, nothing. Nothing is always good. And we now try to look at this spaghetti up here. Jeez, I'm so glad they invented these PCBs. That keeps everything so clean and organized. All right, I think we are good to go. Ooh, got a beep. I really don't like this display here. I really don't like it. So yeah, everything seems to work. We've got 4 bars out of 5 or 6 maybe, I don't know. 53.2 volts, so the battery could be actually fully charged. Almost fully charged, maybe 80-90%. And this is exactly what I need today, because we need to heat up the water. With all the rain outside, the battery shelf and the Gobel tower are down to 4% only. So I need this extra juice. Alright, let me clean this up first. Alright, done. What? No, well, this is the Frankenstein battery, you know? It's supposed to be like this. So I've talked all the bolts again here, all the studs, all the nuts. They're actually only nuts, right? And I have 2 stripped terminals. This one here is super loose, can't tighten it with 4 Newton meters, and this one even came out. Yeah, this one has completely lost everything inside. Jeez. Glad we've got a repair tool here. So first of all, we want to remove. It has even pulled out the aluminium thread here. Okay, that's not good anymore. But what we are using now instead is a 1/4 inch, I think it is, UNC thread. So it looks like this. It is basically the same as this one, just this one has a coarse thread. And it's a 1/4 inch UNC thread, not an M6. And we want to measure 6 millimeters, no longer than 6 millimeters, maybe even 5.5 only, and then counter this with another nut. So the 2 nuts are only there so we don't go too deep into this terminal. Okay, so we line it up, and then with a bit of pressure we drive it directly into the aluminium terminal of the cell. And that's pretty much it. Battery repaired. And we have to do the same on this side here. Let me take off the nuts. It has 6 millimeter diameter as well, and you have to use one of these UNC screws now. Yeah. Balance cable. Hang on. Where is it? Here. Of course, this whole UNC set is linked on my website. Link is down below under the video. Super easy fix, works all the time. Yeah, look at this on this side here. The whole thread is actually coming out. See that? That's the thread. These aluminium terminals were so soft back in the day. Unbelievable. You could potentially measure how deep you need to go in. It's that much only. It's not even 6 millimeters. There's the other aluminium thread. I just pulled off this set screw. Super soft aluminium. And we had this quite often that terminals were stripped. That's why we torqued it only with 4 Newton meters back in the day. And I still stick to it today, even we have much better terminals now. But these EVE LF304 here, these are one of the first ones. Super old. From QSO 2001, they're 4 years old. And the terminals are... yeah. Okay, in good old Frankenstein style, that is good enough. I left the temperature sensors here sitting in the cavity between the batteries and the frame. They measure the temperature somewhere in there. Okay, let's turn on the BMS again. See if it still works. It does. Okay, this is on all 0. Could be this one here, the third one. 1A16S. Yeah, let's... Yep, that's it. Perfect. Here we are. What do we have? A PB1A16S 10P. It is version 14.13. Oh my god, I think this is the original version which is on there. So we need to upgrade this one to 14.25. The links to all the firmwares for version 14, 15 and now 19 is under the video as always. Verify password. Oh, I must have used it already because it uses a different password. It's already set up. 3.45 volts. Voltage protection, under voltage protection 2.6, under voltage protection 2.5. Yeah, that's just the old firmware. 170. Yep, that all looks good to me. Alright, let me update this BMS to the latest firmware and then we can finalize the build. Okay, when I click on connect here, nothing happens. Nothing. No communication. Does it sound familiar? I think we have reused the old cabling again, which I didn't throw away because I still wanted to do some testing with it and to find out what's going on, but it's not working. So I have to replace this smaller cable of these red ones between the BMS and the communication board, and then it should work. Can't believe it. And some of you guys actually saw this in one of the last videos already when we tested or when we did the troubleshooting on the JK-BMS, which didn't want to communicate, and we measured these cables between the BMS and the comms board. And you actually saw that. So this is the faulty one. Yeah, it has an F for faulty. And if I expose it like this, you know, contacts to the top, it is 1 to 1, but backwards. Yeah. Pin 1 is not connected to pin 1 here. Look at this. Yeah, it's a 6-pin wire. Pin 6 on this side is pin 1 on this side. While over here, if I do the same with this one cable, what can we see here? Pin 6 is pin 6 on this side. So, for whatever reason, this one is completely the other way around. So we can easily fix that. We just push down on this metal spring and then we can take out the cable and put this in right order and it will work. But I think there was also a second problem with the actual communication board not communicating with other BMSs. The Victron system showed 3 BMS, 4 BMS, 3 BMS, 4 BMS. And I've got the suspicion that I've put this faulty board into the Frankenstein battery as well. Because I didn't mark this box here. So let's fix up this cable first and then we have a look at the board. So cable number 3. And you have to use an even smaller screwdriver to get into this contact and bend up this little spring thingy again, which we push down to get it out. So cable number 3 here is cable number 3 on the other side as well. Bam! Bombenfest. Okay, let's try again. Connect. And we've got communication. That was the whole problem and you saw it on the video. I didn't realize when I tested the cable that I had these connectors here the wrong way around. So what I measured was totally bullshit and the cable was just wrong configured or manufactured or swapped or whatever. Seems to be stable, 5 online. I've not seen it dropping to 4. Alright my friends, I think the big moment has come and we have to connect this battery to our power wall to discharge it and use this energy so Andy can have a hot shower tonight. The Seplos do-it-yourself kit has actually a film under the lid which isolates the battery terminals and the metal lid. And this is just a thin, like a sticker style, you know. And I remember we put this on and it was a total nightmare. So here's actually a bit of insulation. Alright my friends, I think we have now successfully built the Frankenstein battery here. I finally put the front panel on, the BMS, cabled everything. We reused a lot of these flexible bus bars, leftovers from other projects. I always love to reuse material. Ah, there's actually a hole for the power switch. Okay, I need to 3D print something or just put a screw in there. And I have to try to get all these screws here on the front panel in. I'm not sure if they will all fit. But they don't have to, because it's the Frankenstein battery. Alright my friends, so far this video, I link all the information down below about the Seplos do-it-yourself kit and also this front plate where you can actually mount a JK-BMS into a Seplos Mason battery box. Even it doesn't fit 100%, but it is still not too bad and better than a 3D printed front panel. Guys, thank you so much for 107,000, wow, 239 subscribers here. Welcome to all the new viewers and welcome back to all the existing viewers. Thank you very much for all your support here, buying me a beer, a coffee, a smoothie, becoming a channel member even, and leaving nice comments and sharing these videos everywhere. Thank you very, very much. This all makes these videos possible here. Otherwise we couldn't build a Frankenstein battery. Alright guys, until the next video when we do something different, we don't build a Frankenstein battery again, I guess, I don't know. Well, until then, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. Oh, it has 72% now. How does that work? Oh, look at this terrible mess everywhere. Oh, don't put stuff on the battery. And here the workbench looks like a pig's nest. Oh my god.